All right, team, we're going to start our fourth unit today with taking a look at the coordinate plane and an introduction to graphing linear functions. So for a warm-up, I want you to pause the video and tell me everything you know about the coordinate plane. All right, hopefully you were able to remember a few things. The horizontal axis is referred to as the x-axis, and the vertical axis is represented with the y-axis. We're going to have tick marks. Each tick mark is going to represent 1 unless otherwise noted. So for example, I just plotted on the x-axis 1, 2, 3, and 4. And if I go to the left on the x-axis, that's going to give me -1, -2, -3, -4. If I go up on the y-axis, that's going to give me +1 through 4. And if I go down on the y-axis, that's going to give me -1 through -4. Now, if I want to plot a point, what I do is I'm going to graph the x-coordinate first, so that means I'm going to go horizontally, and then I'm going to graph the y-coordinate, and then so that means I'll go vertically. So for example, if I wanted to plot the point -2, +3, I'm going to go over 2 units to the left, that would be in the negative x direction, and then I'm going to go up 1, 2, 3 units in the positive y direction. So my point -2, +3 is going to be right there. Things to keep in mind is we often refer to different areas of the graph as quadrants, and I'm going to use Q to denote quadrant. So this top right one is going to be quadrant 1. And do notice that I used a Roman numeral to denote the 1. And then we move in a counterclockwise fashion. So there's quadrant 2. This bottom quadrant is going to be quadrant 3. And then finally we're going to have quadrant 4 in the bottom right. One other important point to make note of is going to be this point right here. This point would have the ordered pair 0, 0, and it is referred to as the origin. All right, I want you to take a look at the first example. What I want you to do is I want you to write an ordered pair for each row in the table using the day number as the x-coordinate and then the temperature as the y-coordinate. So you can just think of this as an XY table right here. Maybe I'll make a big X and Y right above it. And I'm just going to start writing the ordered pairs. So for example, on day 1, the temperature was -3 degrees. So I'm going to do X, comma, Y. And then notice I do have parentheses on either end. And I'm just going to keep going. So I have 2, -5, 3, 1, 4, 6, 5, 5, 6, 0, and finally 7, -4. The second part is going to ask me to plot these ordered pairs on our rectangular coordinate system. It does say we need to make sure we label the graph and label the axes. So if the x-axis was day number, we're going to go ahead and say day number on the x-axis, and the y-axis is temperature in degrees Fahrenheit, so that's going to be along the y-axis. And then our title, this will be a little bit long here, will be the daily low temp for 1 week in Sudbury, Ontario. All right, so now I'm going to go ahead and plot these points. So if my first point is 1, -3, 1 in the x direction, -3 in the y direction, 2, -5, 3, 1, 4, 6, it's going to be way up here, 5, 5, 6, 0, and then 7, -4. Now, you might be a little bit freaked out at the moment because you're looking at this and you don't see any kind of discernible pattern or anything like that. That's okay. We're going to take a look at part C now. So part C says, suppose you were to visit, what would you pack on day 8, 9, and 10? So do you know exactly what the temperature is going to be on day 8 or day 9 or day 10? Because I don't see any pattern going on here. But what I want you to think about is if you're packing a suitcase, day 8 through 10 is probably going to be really, really cold. So you need to pack warm clothes. I don't know the exact temperature, but I do know it's going to be really cold, so I need to plan appropriately. Now for day 100, That's too far out. I have no idea. I would need to see more data points, or I'd need to kind of know some history about this particular place to know what the climate would be like. So without further investigating, I would have no idea what to pack on day 100. All right, moving on to our next example. If you're given the equation x minus 2y equals -6, I want you to take a moment and see which one of these three solutions, or three ordered pairs, is a solution to the equation. All right, hopefully you had a chance to plug them in and see what happens. So let's try. What I mean to see if something's a solution is if -6 is our x-coordinate and y is our, or 0 is our y-coordinate, I want to see if I get a true statement. So I'm going to plug in, wherever there's an x, I'm going to plug in -6. Wherever there's a y, I'm going to plug in 0, and I'm going to see what happens. Following the order of operations, -2 times 0 is 0, and -6 minus 0 is going to be -6. So my two sides are equal to each other. That tells me that -6, 0 is going to be a solution to the equation. Let's try the next one. So again, we're going to plug in 2 for x, and we're going to plug in 4 for y. So 2 minus 2 times my y-coordinate, so 2 times 4, is that equal to a -6? Maybe I can put a little question mark above these equal signs to see if they're actually going to work. So let's simplify over here. This is going to be 2 minus 8, and is that equal to -6? Well, it is. 2 minus 8 is -6, so my two sides are going to be equal to each other. So B is also going to be a solution. Now let's try C. So I'm going to plug in -1 for my x-coordinate, and I'm going to plug in 7/2 for my y-coordinate. So is -1 minus 2 times 7/2 equal to -6? And let's see what happens. 2 times 7/2, well, let's see, 2 divided by 2 is 1, 1 times 7 is 7. So this is really going to turn into 1 minus 7. Is that equal to -6? And it's not, because -1 minus 7 is -8, and -8 is not equal to -6. So that means we actually had two solutions for this particular equation. So that's kind of weird. So what is it going to look like if we have multiple solutions? Well, if we have multiple solutions, so for example, if I say let's graph x minus 2y equals 6, I want to see all of the possibilities that are going to make this equation true. So maybe the best thing that we can do to start out with is I'm just going to make a table. And I'm going to have my x-coordinate on the left, or my x value on the left. And then I'm going to have my, what is y going to be if x is, whatever we decide, on the right-hand side. So that's going to be the actual equation over there. And notice it looks a little bit funky. And we were able to come up with actually two solutions in the previous slide. We found that -6, 0 worked, and we also found that 2, 4 works. So I'm going to kind of space those out a little bit because they're kind of far apart from each other with the x values. So I'm going to leave those right there. And now I'm going to pick some other x values, and I want to see what happens. So what I'm going to do is I always like to pick 0 for an x value. It's usually one of the easiest ones to find. So if I plug in x is 0, what does my y-coordinate have to be when x is 0? So that's what we're going to solve and what we're going to find out. So I'm going to plug in 0 for x. I don't know my y value yet. And I'm going to solve this equation to find out what y is going to be. So I'm going to have a little bit of scratch work off to the side. I'll do that in a different color. So over here I'm going to have the equation 0 minus 2y equals -6, and I'm going to solve this equation. 0 minus 2y is just a -2y. So -2 times something is going to equal -6. So let's divide both sides by -2. And let's see what we end up with. Looks like I'm going to get y equal to +3. So how do I want to write this? My y-coordinate will be 3 when my x-coordinate is 0. So that actually gives me about 3 ordered pairs or so. I might go ahead and try graphing these at this point. So I'm going to plot these points. -6, 0 is going to be right here. 0 and +3 would be right here. And then 2, +4 is going to be right there. Now, do you see how those points are falling what looks like to be on a straight line? That's a really good sign. When we're graphing linear equation, so for example, x minus 2y equals -6, that would be a linear equation. We're expecting to get a straight line. If you don't get a straight line, that means I'd go back and double check your math because something's going to be off there. So there's my first one. This is what it looks like to have multiple solutions. Every single point that makes up this line, and notice there's an infinite number of points, I could keep drawing them closer and closer together, those are solutions. So it's a really cool visualization to see all of the ordered pairs that make up this line. Now I'm limited here. I can only draw, what's going to fit on this -10 to +10 grid, but think about how this line could keep growing. What would it look like if it went off to 1,000 or 1,000,000 or infinity in the x direction and same in the y direction? It would never ever stop. So I just want you to kind of take a peek at this graph, and I want you to make some observations. All right, I'll tell you guys what I see. I notice that all of the values fall on a straight line. Again, very important because they should, because we're working with linear equations. I also notice that it's touching, if I go back to my graph, it's touching the x-axis at a particular point, and I want to identify that. Look where it's touching the x-axis. That is going to be what's called the x-intercept. So the x-intercept, it looks like, is going to be at the point -6, 0. It also touches the y-axis. So notice it's touching the y-axis at the point 0, 3. So I'm going to say that it has a y-intercept. We'll talk more about intercepts in just a second. It has a y-intercept at 0, 3. I might also make some observations just about there's an infinite number of solutions. I might also notice like a pattern. If I'm looking between the points that I plotted over here, so if we started over here with -6, and then we went over here to 0, 3, notice I went up to 3, it looks like, and then over 1, 2, 3, 4, 5, 6. That's kind of like my pattern. So I went up 3, and I went right 6. All right, if you want to go ahead and try this one, go ahead. We'll do kind of the same idea here. And I might give you a little bit of a trick for this one to help you find some values. I still want to set up my XY table, but since I don't really have any kind of points to start me out with here, I'm going to have to find them all on my own. It might be nice if I do a little bit of work to this equation x plus 3y equals 3 to make it easier to solve for the y coordinates. So this is where those literal equations come in really handy. So I'm going to solve this equation, and if I make it look like y equals, it's going to be so much easier for me to graph. So let's start by making this look like y equals. So first thing I'm going to do is I'm going to subtract x from both sides. After I do that, that's going to leave me with 3y equals, and then just humor me here. I want to put my x coordinate first. That's going to be kind of a nice habit to get into. So since I'm subtracting x, that's going to be a -x, and then my 3 is positive, so that's going to be +3. Now, this is 3y equals, which is easier than what we had started with, but still not ideal. So I want to get this just to be y equals. So that means both sides are going to get divided by the 3. That's going to leave me with y equals -1/3 x. Remember, there's like a -1 in there. 1 divided by 3 is 1/3. Or you could write it as -x/3. That would be just fine. And then I also have a 3 divided by 3. So that's going to simplify to give me +1. So over here, I'm going to do -1/3 x plus 1. Now, I get to choose whatever x values I want to choose. If you want to choose 0, 1, 2, 3, 4, that's great. You can do it. Use your calculator. Figure out what the y value is going to be. If I look though and I notice I'm going to be taking 1/3 of whatever the x value is, I'm going to say if I pick multiples of 3, my life is going to be a lot easier to work with. So I'm going to pick some negative values, 0 definitely because that's easy to work with, and then a couple positive values. So let's plug in -1. So y is going to equal -1/3 times -3 plus 1. -1/3 times -3, that's going to give me a +1, and 1 plus 1 is going to give me 2. I have no idea how I just changed my color there. So I'm going to end up with the point -3, 2. Might as well go ahead and plot that. Now let's plug in 0. So I'm going to take -1/3 times 0 plus 1. Well, -1/3 times 0 is 0. 0 plus 1 gives me 1. So now I have the point 0, 1. Let's plug in +3. So -1/3 times 3 plus 1. -1/3 times 3, that's going to be -1. And -1 plus 1 looks like it's going to give me 0. So I'm going to have the point 30. I'm getting happy right here because those points are now starting to fall in a straight line. And let's try one more with this 6 for my x value. -1/3 times 6 is -2. -2 plus 1 is going to give me a -1. So 6, -1, great. These are all in a nice pretty straight line. So draw me a nice long line, give me arrows on the end to indicate that it's going to keep going. So we just did it again. We graphed another linear equation. Again, that line represents every solution that works for this particular graph. If we do the same kind of generalizations for this, let's see what we get. I might start again with the fact that, hey, we have a straight line, so that makes us happy. I might make note that multiples of 3 were easier to plug in. Okay, again, it's just kind of like if you think of it, it's going to make your life easier. If you had no idea what I was doing there, that's okay. You can pick any values and you'll get some values out. That'll work. I'll go ahead and take note of the x-intercept and the y-intercept. So let's peek back at our graph. It looks like it's touching the x-axis right here at the point 3, 0, and it's touching the y-axis at the point 0, 1. So x-intercept is going to be at 3, 0, y-intercept is going to be at 0, 1. And if we talk about a pattern here, let's see what the pattern looks like. So it looks like from one point to the next, if I'm going to go up 1, and then it looks like 3 to the left. You could also think about that pattern as you went down 1 and 3 to the right. That would be just fine. All right, as we're finishing up here, I have a few more slides left. I want you to take a look at each one of the pictures, and I want you to find at least 4 ordered pairs for each graph. So go ahead and take a moment and do that. All right, hopefully you found a few points. I'm willing to bet, though, of the 4 points that you picked that one and that one, and you probably did a few in the middle. Well, what you just found here, so it looks like this might be the point, I think that's 16, 0, if I can read my tick marks, and it looks like the point over here would be 0, 12. You just found the x-intercept and the y-intercept of the graph. And again, over here with this polynomial function, again, this is just for fun. If you were to pick 4 points, you probably picked those 4 because they're the easiest ones to find, and I feel really confident about where they fall on the grid. So this particular polynomial, so this would be fun in college algebra if you want to take it with me in a couple of semesters, we have, it looks like 3 x-intercepts. We have an x-intercept here at the point 2, 0. We have an x-intercept here at the point -1, 0. And we have an x-intercept over here at the point -4, 0. And then there's only one y-intercept. And this looks like the point 0, -2. So those were probably the easiest points to find. So I want to generalize here. When we find intercepts, so when I find the x-intercept, let's see what we're doing, okay? First off, let's define it. The x-intercept is where the graph touches the x-axis. Whenever you touch the x-axis, your y value is going to be 0. So we're going to plug in y equals 0, and you can solve for x. Okay. As an ordered pair, this is going to look like something, comma, 0, because you're going to find out what the x value is when the y value is 0. Now, it's going to be a very similar idea for the y-intercept. The y-intercept is where the graph touches the y-axis. And how we're going to do it? Well, if you touch the y-axis, your x value has to be 0. So you're going to plug in x equals 0, and then you're going to solve for the y-coordinate. My screen's not letting me move it down, so here we go. What it's going to look like is you're going to have x is 0 then, and then you're going to figure out what the y value is. Okay, now let's do this in action. Oh, whoops, my equations didn't show up here. I'm having a little bit of issues getting my equations to work. So equation A is going to be negative 3x plus 2y equals 8. And I want you to go ahead and find the x and y intercepts for this particular linear equation. So here we go. This is how I like to organize mine. When I find an x-intercept, I like to remind myself that the y value is going to be 0. So I'm going to go to my equation. Wherever there's a y, I'm going to plug in 0. So I'm going to have negative 3x plus 2 times 0 equals 8. And now I can solve this equation. So negative 3x plus, well, 2 times 0 is 0, and negative 3x plus 0 is just 0. So I'm left with the equation negative 3x equals 8. So let's go ahead and get the x all by itself, and I'm going to divide both sides by negative 3. And that's going to give me my x-intercept. It's not pretty, but it's negative 8/3. If you want to write it as negative 2 2/3, that's just fine. But my x-intercept is going to be at negative 8/3, comma 0. Now let's go ahead and do the same idea, but let's find the y-intercept. So I do the same setup. I do y-intercept, and then I remind myself that the x value is going to be equal to 0. And here we go. Negative 3 times 0 plus 2y equals 8. Negative 3 times 0 is 0. So 2y equals 8. And now I can divide both sides by 2. Oh, this one looks like it's going to come out much prettier. So y is going to equal 4. So let's go ahead and write it. X was 0, y is 4. So those would be my two intercepts. So say if you were asked to graph this equation, negative 3x plus 2y equals 8, that's going to be way easier because now you already have 2 points that are going to be on the line. All right. I just want to talk lastly here about special cases. So special cases, we're going to have two special cases. We're going to have a special case where it's a vertical line, and we're going to have a special case where we have just a horizontal line. Now, when we're looking at a vertical line, for example, it might be something like x equals 3. What that means is every single x value is going to be 3. So if you were to, for example, make a table of values to try to graph this, your x's would all be 3, and your y value would be whatever number it's going to be. That means your x doesn't change, but y can be whatever. Okay, this says every x value is 3. That means your x-intercept is at the point 3, 0. And then this means there would be no y-intercept. If we actually think about what this graph looks like, if every single x value is going to be 3, well, I'm going to go on my x-axis and find 3. So here's all these different points that have an x value of 3, and that's going to give me a vertical line. So that's what that equation would look like. Now, its counterpart, the horizontal line, is going to be something, for example, like y equals, let's get creative here and say 3. What this means is every single y value is going to be 3, and then x is going to be an arbitrary value. Okay? Over here, we're going to have every y value is 3. So this would have no x-intercept, and it would have a y-intercept at the point 0, 3. So if we were to take a look at this picture, I'm going to go up to 3 on my y-axis, because all my y values are 3, and I'm going to put a point here. And I'm going to keep graphing all of these points that give me a y value of 3. And notice it doesn't matter what the x value is, it just is going to be represented by every single possible x value. So this gives me a horizontal line. A really common misconception is that people think an x equals equation should be parallel to the x-axis, and that's not true. It's because every single x value is 3, and same with the y equals 3. People want it to be parallel to the y-axis, but no, it's every y value is 3, so that's going to yield that horizontal line. Your homework for today is going to be in Connect Math. Please drop into virtual office hours if you have any questions. They're going to be every Friday, and please don't hesitate to email me. Thank you so much, and I hope this was helpful.